We live it 100 years in just 5 years, right?
Let's embrace this age that we are right now and embrace this creativity with these LLMs.
Hello, everyone, and welcome to the Humans of Tech, a CI&T podcast to talk with humans who are changing the world with technology. My name is Rodrigo. I'm an engineering director at CI&T today, and I'm here with Mika and Gabriel, and I would like to let them introduce themselves. So, Gabriel.
Yeah, I'm Gabriel. I'm excited to be here. Thanks for inviting me. I'm a former employee from CI&T, worked there for 5 years as a lead data scientist, and now I'm at NVIDIA in a position of senior applied researcher. So my first years at NVIDIA was working on recommender system. My PhD was in this area at the Brazilian Aeronautics Institute of Technology, ITA. And since this year, I have been starting playing with large language models, in particular with retrieval augmented generation. So happy to be here and share with you.
Great. So my name is Mikaeli. I'm working as a AI machine learning leader at CI&T. I also have a master's degree at Unicamp, working mainly with AI as well. Google developer expert in machine learning, and also a Microsoft most developer professional in AI. So very nice to be with you guys today.
Awesome. And if you hadn't noticed from our colleagues that are here now, but we're going to talk about AI today, right? And it's fun to see AI has been gaining a lot of traction. And I know that because even my mom now has a point of view on ChatGPT and how it can impact the world. So when that happens, I know that the world is changing and something is happening. With that said, there's a lot of moving parts. There's a lot of this technology. But I'd like to start this conversation, if you like what are these large language models, right? Where do they differ from previous models? What is the big aha moment that happened with them? Why they're so powerful?
Yeah, maybe I can start. It's impressive. We live it 100 years in just 5 years, right? Since the release of Transformer paper in 2017, things changed a lot, and we might talk about Transformer in a bit. But I think in general, large language models are probabilistic models that try to predict, in a sense, what's the next word given a sentence or given a text, right? So they're trained to autocomplete. So when you use your smartphone, typically there's an autocomplete feature that predicts the next word or the next letter, right? When you're just writing some message in WhatsApp So that's basically a model that's running that statistically tries to predict what are going to say next. The whole idea of the language model is being trained to do so, and it uses to use some techniques that are able to lead with sequence of text. For example, in AI, we typically work with deep neural networks, right, which are structures that try to loosely mimic our neurons in the computer. And then there was some models that were used for this test, for example, recurrent neural networks that try to take the sequence and predict what's next. And it's used not only for NLP, right? It's used for stocks forecasting, time series forecasting, right? For any problem where you want to predict what's next. And then in 2017, the Transformer paper was introduced. And the key difference there was that it's able to deal with much longer sequences and compute that in parallel rather than sequentially. So that really enabled neural networks to deal with long sequence, and in particular for large language models where they are trained on very large chunks of text. It's a key property, right? Be able to train on long sequences and learn patterns from it. So that's where we started to have the large language models, right? Where we're able to, those are models that are trained on trillions of tokens. They have billions of parameters, and they're really powerful on learning patterns. But they work just like parrots, right? They just try to repeat or to remember what they read before, right? And for experience, like when you want it to perform a task, and it's to follow instruction or to ask a question, that's not very useful, right? So typically those models are pre-trained, just like I described it, by learning those, try to predict the next word and learning patterns from it. But then there's a second stage which is called fine-tuning, which is where when you take you prepare data set to our you don't care much about quantity in this second phase, but more about quality. So typically you have human labelers that provide examples. Oh, okay, so given this instruction and this context, perform this task. So humans provide examples, and that's called the first phase is self-supervising, right? But this one is supervised training. And then you might provide examples, for example, on how you should answer to open-ended questions or questions to your own domain. Or, for example, typical natural language processing questions, for example, given this passage or given this document, this is the type of summary you should provide. Or teach it how to extract entities in a given text. So you provide examples to it, and then those are in smaller quantity but in higher quality. And then we call that adjustment. We are adjusting the large language model to perform tests that you expect it to work on, right? And in particular, there's a technique that really made a difference for GPT-3, right? So GPT is a family of decoding models which are able to generate text, and that's the core inside, for example, ChatGPT, right? So they developed the GPT models, and it kept evolving. And in GPT-3, they introduced a technique called instruction fine-tuning and reinforcement learning with human feedback. So what's the idea? You train the model to accept in the prompt some instruction on which task it should perform. And when it generates, let's say 3 or 5 different outputs, because these models are really, they are not deterministic, they're stochastic, they're generative models. So you might run it with the same prompt and it might generate different output. And then with this reinforcement learning with human feedback, the humans labelers are expected to select from the outputs which one is more suitable for that answer, right? Or more human-like, because for models that are trained to just generate the next word, you might not expect they will generate some answer that's more accepted, or that follows the ethics of the company. So we really want a human to kind of guide or align this training. And by doing this process, that's where you start getting outputs some close to, for example, ChatGPT, right? Where it looks like you're talking with a human because the response align with what a human would expect. So yeah, I talked a lot. I would be interested to also hear from you. What are your thoughts on this?
Yeah, so I totally agree with you that it had a great impact, the large language models, and what helped us to have this huge effort on to implement AI in our companies and this rush to talk about it. I believe that in March this year, we had the launch of ChatGPT, but we were talking about models focused on NLP since, 9/16, where we had this, a lot of people started talking about RNN, this LSTM. So it's not today that we are discussing models applied to language, but it was because of this huge compute that we have nowadays, as well as this transformer architecture that has been launched with the Attention is All You Need 2016. And also with these large documents that we were able with the compute and also with this large amount of data. And then it allows us to have these models working for us. And we call that foundation models, right? Because on top of these foundation models that we have, like, for example, Chat Bison, we have GPT 3.5, GPT 4, as well as Llama 2, Llama. We have these models working for us, and then we implement our solutions on top of them. And just to bring some data to our conversation, when we have, for example, Llama, we have like to train Llama, not the second version, but the standard one, we have like 2,000 GPUs working for 21 days. So that's huge when we talk about like, let's say I want to implement these models in my company. So we would not say to you like start training from scratch. This is not what we would do, because these models take a lot to be trained. And this data that I just showed you represents, for example, one house with 4 people living there for 10 years. So when you talk about like, it's not like, well, let's stop the city to train these models, but it represents a lot of energy consumption and carbon footprint in your environment. So that's huge. And in terms of dollars, it would say like $5 million to train this model. So let's start using these models per training models instead of training from scratch, right, guys? So I don't know what you think, Rodrigo, but that's like an advice, and that's what we would do and what we're doing here in our company. And that's it.
Yeah, you bring a good point when you talk about like how expensive these models are to train and run, but they are very powerful, right? When we think about that, and I like to Gabriel remember the RNNs. I still remember the first time that I coded my first RNN in college. I was doing my scientific initiation, and it was quite interesting to see the computer think. Although we could understand only, I don't know, 3 sentences in a row. More than that, it just forgot the beginning of the sentence. I think that was the major flaw in design with the RNN for the NLP, right? Long text was really challenging for it. But going back to your point of, yeah, it's a lot of energy, but once you train, we can actually automate a lot of tasks, and we can actually use it for so much good. Like, used correctly, it pays itself out, even with that huge carbon footprint or anything, which is pretty interesting to see technology evolving quite fast. And you mentioned like 2017 was the transformer, and shifting gears to transformers, I think that's a good topic for us to go forward. The transformer architecture was quite revolutionary in many ways. I was even watching the other day an interview with Elon Stuttier, or the chief AI researcher for OpenAI. And he mentions that transformer is actually the double helix component of the technology in terms of double exponential, right? So it allows us to go faster, because now transformer can be applied to other elements of AI, not only NLP, but other branches of AI that traditionally we had other architectures. So I thought that was very interesting on how transformer can actually be an architecture that it can leverage for multiple purposes in AI. But in order for us to like, what is the transformer architecture, right? Why it was so revolutionary? Why it allowed us to actually do things in parallel? What is the biggest element with the transformer?
Yeah, so I believe transformer is really key and the secret weapon of this revolution, LLMs, right? And it's not about the movie Transformer, but it's really, yeah, it was a cool name. But it's ability to pay attention to what matters, right? So us as a humans, we always do that, right? Unconsciously, when we are in an environment, you used to pay attention to what matters. You see, from what you are seeing, you see some danger coming, for example, you pay attention to it, or something suspect, or something that you think you can leverage to achieve something, right? So as humans, we do that. That's selection. Not all information is useful at a given point of time. And that's what Transformer has built in, this attention mechanism, right? And it's called self-attention because it looks to the inputs themselves. So when we talk about recurrent neural networks, they are kind of limited, as you mentioned, Rodrigo, in terms of sequence length, because they try to encode a sequence of different length, even using the same memory inside the RNN, you have what's called hidden state. It keeps the memory of the network. So if you increase the length of the sequence, you still have the same limited number of weights or parameters to memorize all of that. So that's why for a longer sequence, you start having this problem. And what self-attention allows is that for every step of the training of the sequence, it's allowed to access the previous, depending on the training approach, right? You can either access all the previous states or positions of the sequence, or if you're training using masked language modeling, you mask some of the positions and you give it as a context access to information of all the other positions of the sequence. And that allows it to, so the longer the sequence is, the longer the sequence, the more memory you give it, you give it to the model, right? So it has access to past and future information, and that allows it to pay attention to only what matters. And in addition to that, it's more efficient, because for RNNs, you need to feed the first element, take the output, and then insert the second element as input, and keep doing this. But with the self-attention mechanism, you feed the inputs for the whole sequence at once to the GPU, and you go layer by layer, because those models are very deep, but you don't have to process the sequence anymore. So that's much more efficient, and that really allowed for deep learning and deep NLP to get much better results with this type of architecture. But basically, in transformer models, you have an encoder and a decoder, right? And an encoder is a bunch of stacked layers that use this mechanism of self-attention, right? And then in the end, it generates a representation of that text. And then in the decoder tower, that's able to generate the output, it's allowed to attend to those different encoders and have access to the whole input. And you keep going deeper and deeper, and there are many techniques there, like skip connections, and that allows you to be able to access the full information and provide a good answer. So in general, that's how transformer works. Not sure if Mikhail would like to complement.
Yeah, and in addition to the self-attention layers, we have the multi-head attention layer, right? So the difference is that mainly it would do the same procedure as Gabriel just mentioned, but in parallel with multiple heads. So it allows us to also have this parallelism and also take advantage from this compute, this numerous GPUs, and then we can like train with a huge corpus. That's what we call this large amount of text, right? So this is very, very powerful, and that's what I believe that it's very interesting and allows us to, for example, when you have like translation, we may think that, okay, I can get one word in English and do the direct relationship to another word in French, but it's not like what it is in the real life, because you can have, for example, one whole sentence that can be translated to a single word in another language. So this transformer architecture is very powerful because of that. It has, for example, the positional encoding, when you can see how does it works with a single word and its relationship with the position in the sentence. And this whole architecture allows us to get these value vectors and then multiply with dot product and this dot product will tell us, okay, this vector here, and we are very math here. We like math, guys, so that's why we're talking about it, but it will make sense in the end. Let's say we get a word, and then we get another word, for example, and then we will translate this to floating points or vectors that will make the computer able to understand the meaning of these words. You can say, okay, this word here, this number is related to this number, and they're going the same way, the same direction, and this will tell the compute, okay, so that's why these words, they are similar. So like, for example, when I have a car and I have also a bus, they are similar each other because of the vectors that they are representing the space. And then you can say, okay, so I can maybe change one word to the other because of this position that they have. So that's how it works. We don't have those strings to the compute directly. We have to translate them to vectors, and that's how this all the system they can understand, right?
Yeah, I'd like to thanks, Mika. I'd like to add a comment on the sequence length, right? Because you see that there's a limitation. Many APIs when you try from OpenAI, from Google Palm, there's a limitation in the size of the context you can provide, right? And that's because in the original transformer architecture, there's a quadratic complexity in terms of the sequence length, because for every word in the sequence or every token, to be more technically correct, it needs to attend to all the other tokens. So it's quadratic complexity, and yeah, it increases a lot when you work with longer sequence. And then some architectures were proposed to deal with this problem, like long former, lean former, and more. And Mika mentioned about the position embedding, right? So that's how the transformer can have a sense on the position, right? On whether two words are close together or not. Because without it, it wouldn't know the position of the word. We remove the sequence, and we use the position embedding that's summed with the token embedding to give some context of the position. And networks are trained like that, using the position embedding. But during inference, you sometimes want to be able to fit longer sequence, right? Because you don't have the cost of the back propagation. You can use the same GPU and use longer sequences now, because you just need to do the forward pass, but your model was trained with less shorter sequence. And there are some research techniques called, for example, alibi or rope, that Hugging Face, for example, provides built-in, that allows you to do inference with longer sequence than the ones it was used for training, right? So, and you keep seeing this challenge, right? This competition where the APIs are able to support longer context or longer prompts, and that's really enabler, because then you can almost feed now for OpenAI, for example, you might almost feed a chapter of a book or the full short book and ask questions about it, right? And that really enables you to do some in-context learning, which we might talk later. But yeah, this ability of leverage external knowledge to enable the LLM to respond answers to questions that it has not seen before.
That is pretty cool. And I think what calls my attention is, funny to say, calls my attention with the attention that we just discussed. But anyway, what calls my attention is, from a really high level perspective, what transformers allowed us to do was quite simple. It just allowed us to do things in parallel instead of doing things in sequence. So with RNNs, we needed to read a book, or AI could read a book the same way as mere humans do, which is sentence, word by word, sequence by sequence. And with the transformer, it now can read all the words in the book at the same time, given challenges with the input aside. But that's what allowed us actually to have training massive data sets that were quite challenging before, just because of how much time it consumed. And now it just became a problem of having more GPUs around, which is quite fantastic if you think. It's a simple, from a high level, it's very simple, but very powerful concept. It's pretty cool. But going to one thing that you guys talked a little bit, I think Gabriel was the one who mentioned, like, the ability that LLM has, that you give it a little bit more context, right? Or you give it some context, even now bigger context. You can give it information. It can perform several tests on top of it. So it gives it a lot of flexibility on how people can use it, beyond on where it was trained for, right? Beyond it was trained on a certain amount of data. Now you can feed other data and actually gain from it and use it. That gives a lot of flexibility. So my question is, can we use LLM for everything? Like, in the future, we will not see any other AI or machine learning algorithms going on. We're just going to leverage LLMs. It has that flexibility to be used for everything that we want, or do we need to take care of some other topics?
Yeah, that's a good question, because all AI conference at this point, and all blog posts are just talking about generative AI, right? That's where it really catches the eyes of the investors and the humanity in general and our grandmothers. But yeah, we know that AI is it typically was divided between discriminative and generative AI since the beginning, right? So for in discriminative AI, the idea is to give an input to automate for example, a classification or a regression, right? Estimating a continuous number given the input. So we might think about, for example, I work a lot on recommender systems, right? So the task is to predict what's the next item the user might be interested. That's a discriminative task because the items already exist. You're not generating new items in that sense. You're just choosing the ones to show to the user. If you think in finance, you might want to predict what's the stock price of this this stock tomorrow, or you might also classify which customers are going to churn in the next 3 months, or is this transaction fraudulent or not. So these are all examples of discriminative tasks, and they will continue to be, right? So the traditional techniques will continue to be used there because they are efficient, they are fast, the models are much smaller, and trained with supervised adaptation. So yeah, that is going to continue, right? On the other hand, that we have the generative AI, right, whose objective is really learn a model that's able to generate something that looks like similar to what's real. So it might be an image, it might be a text, an audio, right? For example, when you take a text and ask the computer to read it, it's generating text from another modality, which is the text. So those are really powerful because they look like human-like, and they help a lot to automate things, right? Because we as humans produce content, right? We produce content all the time, and those generative models really matches increasing our productivity, increasing the quality of our work. So they are here to stay, and more we'll see generative models in our daily lives, in our job workflows, in our conversations. But yeah, definitely there is space to the other types of AI that are really enabler and much more efficient. They use less compute and are very specialized for specific tasks that, like some I mentioned.
Yeah, and it's even easier for some companies to leverage AI due to the it's very fast to implement like POCs or like create new agents with this tool. And it was very hard to do that if you don't have like a AI team in your company in the past years, because you would need to like have a data scientist, a machine learning engineer to create these algorithms from scratch. So if you don't have like this budget or you don't have this team, now you can like do this very fast with some APIs. So I see that not just the LLMs, but the big techs, they allowed these companies to try like AI in a way that they could not do this in the past. So that's something that I don't see that we have like a return. You cannot go back. That's something that as soon as we saw this usability, like this user-friendly way to choose these models, like the API, so on and so forth. So it's very nice and something that I just see that it's like a market that will just increase. The only downside that I see, and I'm very concerned on that, is the hallucination. So imagine that you have like a fraud detection problem to tackle. LLMs are something that's it's not for this business is particular, because you have like logistic regression models, something that have already worked in the past. So why would I use LLMs for this? Because one, I'm not generating anything. I must have a deterministic result. So it's very important for us to like see the business requirements, maybe ask the LLM to generate a fraud detection algorithm for me, but not use LLMs as the algorithm for me. So I would say that it's important to understand your business requirement, your problem, and maybe see if, okay, LLM is going to be used for me as an input for my resolution, for my result, or LLMs are going to be used as the tool for me to address this issue, this problem. So this is my takeaway when I'm using LLMs and for the future as well.
I think you bring forward two important topics, Mika. One is, I think part of why AI is in such a hype, we made it easier for non-AI engineers and to consume the outcomes of AI, right? The idea of having an AI-powered API, you just send text and get text back. It's very powerful in the simplicity for us to apply to multiple scenarios. You just saw the amount of startups and companies that started adding powered by AI to their offers. To CI&T is one example, but a lot of other companies going through that. But you touched a subject that I think is quite important when we're discussing AI, which is hallucination. And basically, what is the trade-off, right? What are the catches? So hallucination is for sure one of them. That, according to some research, are the top concerns of multiple companies. But do we have any other catches, any other trade-offs, things that we need to be concerned about when we start exploring the use of this technology? Gabriel, what have you seen with your experience now, and what are the trade-offs that we need to take a look?
Yeah, hallucination is definitely a problem because, as Mika said, it's not deterministic. And some assistants, for example, ChatGPT, it tends to defend his position, even, for example, it might give an information that's not correct, and then it insists it. If you tell it's wrong, it might say, okay, maybe I'm wrong, but I based this information on this, so it keeps defending his position. And for applications where you need deterministic output, you might not trust much sometimes in the output, right? So using LLMs for discriminative tests, like I mentioned, might be tricky, right? So that's definitely a concern. Another one is the model size, right? Maybe it's much more than you need, right? It might, for some simple tests like text classification, for example, what are the topic of this email or this ticket in the system, or what are the topics? So doing that in either supervised or unsupervised way, it might be over-engineering. If you have large crops using an LLM to do simpler LLM tasks, or tests that you could easily accomplish with an actually boost model for classification, or for some regression tasks. So those are some examples of simpler tests that you can accomplish in different ways. And if you want to expand, there are other challenges too, right, related to LLMs. For example, one is privacy, right? So you don't want your company documents to be ingested by these external APIs, for example, because it might be critical to your company, and you add all layers of security on your data, but then you decide to, in order to use a powerful tool, you just send them through the API to the internet. And the more you can trust in those providers, but it's really not compliance with your security. And there might be also PII, right, personal identifiable information in your data that you don't want those LLMs to be used to be able to use either for training or for inference. So those are some of the challenges that companies are worried these days.
And in addition to that, I would say like the API is very important, as Gabriel mentioned. And when we work as a machine learning engineer, for example, you are responsible to create your own infra to manage the Kubernetes, the pods, the requests, if it's going to be batch or streaming, a lot of things. But you are in the control of this whole infrastructure. Now, when we rely on the APIs that the they are bringing to you, like it's easier for you to have your idea in place because I mean it's just like a request. Everyone can do that. It's easier to test. But at the same time, when you move forward to the production phase, you have to have your accountability and how can I make sure that these APIs are going to still be 24/7 when my customer needs the results of these LLMs. As well as, let's say an example, we just mentioned hallucination. How can I make sure that I will have like a guardrail that will not just um, be make sure that there's no PII from the customer side to the LLMs, but as well as make sure that the output of the LLMs is okay. There's no toxicity to be sent to the customer because we have no control over the data that this company is training their models on. So that's very important. We make sure that we implement the guardrails and at least try to address something that's related to responsibility AI or fairness as well. And as I mentioned, related to infrastructure, I would like to point out about the GPU availability because, okay, we have a lot of open source models, but to leverage them, to make sure that you can take advantage of these models and put them in production, you have to have your own infrastructure and be able to productize them. And when we reach this point, we request GPUs, we may fall into the issue of availability because, for example, Windows is now coming to the market already with the GPT inside the search. So you now can you just we were used to, okay, I entered the ChatGPT and then I asked some question. But now you can do that in your own computer without even accessing your browser. So if you want to make like a dark appearance in your Windows, you want to change the colors, you may not go to the settings right now. You can just ask in the language that you are used to talk with your neighbor. You can now use to Windows. So that's why Microsoft, Google, all of them are needing, they need GPUs. Now, when your customer wants to use your GPU, you may find the problem of availability. That's why it's very tricky, and we are more into the going forward using APIs and these LLMs that they are already in place for you to access. But that's why when you are implementing this, you may be very concerned to have like, okay, what is the strategy that I'm going to use to have these APIs in place when I need? So am I going to create different subscriptions? Am I going to, for example, have not just OpenAI, but also like go to Palm, go to Anthropic, go to other LLMs like Llama, to have like a way to have a resilient operation. When I need the request, they will be there for me. So it's very important to be more agnostic and try to leverage a lot of LLMs to be able to make it feasible.
Yeah, I'd like to add another challenge that is LLMs are limited to the content they were trained, right, and to the time it was trained. And word is changing, right? So I did a test these days in one of the APIs. I asked it, who is the coach of the Brazilian soccer team? And it said, okay, it's Titi. It's not, right? So we have a new coach this year, and it's 1 year outdated, right? So that's one reason that's one limitation of the current LLMs. They really are stuck to the content they were trained on, and they don't have access to current information. And in the companies, you typically have, for sure you have updated content you would like to leverage. Maybe some content that's private, you would only want your employees to have access and partners, right? And an increasing trend in this area is to use a technique called retrieval augmented generation, which basically, instead of fine-tuning the LLM, you just provided high-quality context information that allows it to respond to questions that they were not trained upon. So say you have some documents that talk about some procedures of your company or some manuals of some tools your company has. Basically, given a question, a retrieval system is used to retrieve relevant paragraphs that provide some context on how to answer that question. And then the LLM is provided the question, the retrieved passage, and it can use its own knowledge to generate the answers, right? So that's a key trend. It's more efficient than fine-tuning an LLM. There are techniques for sure to fine-tune LLMs when needed. So when your use case is very specific, and for example, let's say you're applying your LLM to legal or to medical, right? As the open source LLMs were trained typically on Wikipedia documents, not specifically to domains like laws, like medicine, right? They don't have the right lingo. So then you can fine tune. You can for that same task of predicting the next word using some techniques called parameter efficient fine tuning, in which instead of training all parameters of your model, train say less than 0.1% of them, and then you are able to achieve the results. But in many cases, for general non-domain specific problems, using this technique of retrieval augmented generation and plugging a search engine to your LLM, you are able to provide enough context for it to successfully respond the answer that it was not trained before. And this is not limited to text. Companies have database, right? Data warehouse. You might have, if you're an engineering company, you might have an AutoCAD project, right? You might have different types of data. And this is a current challenge in research, and that companies also face, right? How to plug this company information that's not just text. Tabular information has a semantic here. Theirs has a structure, right? And you might have also other types of information like image, text, audio, 3D projects. So there's a trend in research on how to leverage those different types of information, so that you are able to, a system is able to answer questions based on them.
I think you bring forth a very cool topic, which is how to leverage this technology on this day-to-day. And I like that you brought on that fine-tuning versus RAG. And our learning as well has been what you said, like RAG, it's much more powerful and in general terms require a lot less data for you to have awesome results than fine-tuning. Fine-tuning is very tricky, very complex to do. It's a highly complex operation. So when we think about business and companies that are trying to onboard this technology, what do you see as the path that it should take? How do I start bringing those technologies to inside my business? It's about selecting use cases. It's about starting with anything. How do you see good approaches for us to start bringing that on?
Yeah, that's a very good question, right? Because there are so many use cases, right? If you work in med tech, you might give some tool to help doctors or physicians to have access to the latest information, right? They don't have much time to read papers, for example, but they could put some symptoms or some disease and get the latest information there and get the LLM summarizing a large amount of context to point him to the right path, right? For e-commerce, for example, and recommender system, right? Instead of recommending items, you might want to generate items, right? So, for example, the covers of Netflix items are personalized per user already, right? So there are many use cases out there. It really depends on your use case. But in general, if you have a generative task for machine learning, you could start, for example, just trying out an API that's out there and preparing some prompts and seeing if the knowledge that's already in those LLMs is sufficient to respond successfully to your use case. You can use it either internally to improve your process, I mean the productivity, the quality, or you might plug it into your user-facing tool to help users, for example, to customize things in your application. Maybe that does not suffice, and then maybe you need to provide some examples to your prompt, right? Maybe you might say, okay, let's say a developer wants the system to mine a text to find some geographic locations and output a JSON that provides that that information that extracts, okay, what are the locations mentioned in this text so that I can put them in the map, right? So we can provide examples to the LLM so that it learns, okay, well, what's the desired input and output that I should take? So that's a way to instruct on the LLM how to perform a task by giving examples, and that's very efficient, right? Maybe that does not suffice, and then you might want to fine tune to your domain, as we said, and then finally use the retrieval augmented generation. When actually I would try the retrieval augmented generation first before trying to fine tune, because it's much easier. You can do the search yourself, just add some context to the prompt and see if that's enough for the language model to generate a successful output. But yeah, going incrementally, I think it's the key, right? And with from the lowest complexity to the highest one.
And the first prompt that you create may not be the best one and will not be the best one. It's like an iterative process. And you can leverage a lot of techniques to improve this prompt, as Gabriel mentioned. So the few shot, when you give like a bunch of examples for the model to understand, okay, what's the reasoning that I have to get this output in a better shape, right? And for that, for example, there is the chain of thought when you have a bunch of examples with the reasoning, instead of just putting the example direct with the output, you have already the result. You move forward giving like the ways that you use to tackle this problem, and you give this to the model so that it learns the way to solve this issue. But the chain of thought was something that it was generated this year, but it's already in the past, because now a way to tackle, for example, the hallucination was the react, where you have the thought, you have the action, you have the observation. So let's say, for example, I want to use these models, but oh my God, I'm having a lot of issues with hallucination. One way to face this would be, okay, getting output like results from the environment. So for example, getting from my documents, so getting from the search in the web, so that I'm more reliable with the information that I'm giving to my user. So a way to do that is, okay, I'm giving for the model like a thought, like let's say I have to build a house. And the model will be responsible to, okay, map what are the actions that I needed for me to build this house. One of the actions would be, okay, I have to get woods. So I may go to my database, I may go to the web, search what is important, like mapping to a real use case, mapping like what are the news, what are the business that I need to tackle this activity. I bring to the web this information, and then I can map to an observation. Okay, this is what I saw, and that's how this helps me to tackle this issue. So the React was something that has been in the papers for a long time this year. Like, say a long time is very tricky when you talk about AI, but this year, like some months ago, and it's been a technique very powerful for us to complement with RAG, with chain of thought, to have more important results and reliable for our customers. So I would say that RAG, it's better for you to start. I wouldn't go to fine tune. This one is very important for use case, and the RAG is not being something that is in total like powerful for you. But I would start with some prompt techniques for you to have a better results.
Yeah, that's a good point, right? Because there's this concept of agents, right? And agents, they really go through this process described, Mika, to decide what to do next. So you start giving tools to these agents, so they think, okay, I need to build a house, like you said, but they don't need to know how to build a house. They just need to know which tool they can use for that. And we have many specialized tools in software stack in general, right? So that's really powerful. It starts to be more proactive and more and have using LLMs for what they are good for text generation. They start to reason, right? So that's a really powerful concept that we're going to start to see more and more. Yeah, that's pretty interesting.
Yeah, that's why we see a lot of companies using, for example, LangChain, because LangChain is very powerful to do that. Mechanism to have these agents. You build an agent, but you have some tools that will help this agent to finish this objective that we just sent to them. So, for example, you have a calculator, you have like a search in the web, you have some search in my private documents, and then when you say a prompt and you ask for an action, the agent will see what's the action that is more similar for me, more important for me to finish this problem that I just sent them. So that's very important because it helps us to have a more something more deterministic in a situation that is totally non-deterministic, like to be more in control over the output, right?
Let's start with like simplest terms or the simplest models. I think that bodes well with most organizations, especially because it's a new technology and deploying new technology is hard. But it seems to be a consensus between the two of you that RAG seems to be the easiest approach to start, where you actually feed it some new information and leverage what we just discussed about the ability of LLM to get new information and run with it, right? So leverage that part of it and start from there on your own use cases. Pretty cool. I would like to take a different approach on how to start. We said about companies, but what if I am a person now? Like I'm involved with technology. I might like it, or I might be an engineer, but I want to get started with more details or more involved with AI. But now generative AI got my attention. How do I do that? And since we have in here like engineering and scientists, I might ask you guys, can we answer that question from somebody who has a heart of an engineer who wants to focus on solving the problems in the world, or somebody who has the heart of a scientist who wants to deeper develop the technology? What are the paths that these folks can take to actually start deep diving in these discussions?
I can say for people that starting is that this field has changed so much that either experienced data science and machine learning engineers are refreshing themselves with the new tooling, the new type of test, and the new type of approach. So we are starting right now. We are still in a good time to start, either if you are a developer or if you want to pursue a career more on the machine learning. Tools out there, I'd recommend you to start with some platform that gives you all the components you can play with, right? So you might want to start with some APIs like OpenAI and start learning about some prompt engineering. If you're a developer, you might want to learn about, okay, how can I call a function or a web service? How can I have an LLM calling a function or a service? How can I prepare the prompt for that? Because that really enables you to easily connect an LLM to your application and create an interesting interface there. And so definitely prompt engineering is a good thing for you. And understanding this tooling, right? These platforms like Mikael mentioned about LangFlow. There's also Llama Index, Haystack, and this is a very dynamic field. There are many tools that are being created, but those frameworks are kind of connecting all the pieces together. So they're checking their examples is a good way to start for sure. And if you are on traditional, I can say that now, traditional machine learning, right? Using traditional, neural networks that are non-transformers or different types of models, you might want to take some courses, read some papers to understand about these new architectures, right? And what they can accomplish. And maybe you might be surprised that some of those traditional models are not really needed anymore with this type of technology. So yeah, there are different learning paths, but definitely encourage you to start now, right? Things are changing fast, and there's not much advantage on someone that's 20 years in the field and has not looked closely to what happened in the last year. So you don't have much to look back because everything has changed now with this generative AI revolution, I'd say.
Talking about the science part, a lot of data scientists, machine learning engineers, they may be afraid, like, okay, everything is LLMs right now, and if you have to like see, okay, am I able to tackle this problem easier, faster with LLMs? So why not? Okay, so let's embrace this age, see what is better for you, what makes sense, what we can leverage from it, and then ponderate, like, okay, let's say, I can use LLM, so why not? That's my main takeaway, because a lot of things changed, but it's very important to like see the architecture, see transformers, what are they bringing, and how can I test? And then you can go to the second phase. Okay, how can I make sure that my prompt will be, what's the time, when it's time to improve my prompt, when it's time to like have like a metric to see if my prompt is good or not, if the result can be improved. So as a scientist, try to see like metrics, try to see how you can improve these prompts, because if you fight against LLMs, it's not going to be something that's going to work, because they are very powerful. They can do a lot of things that we would take a lot of months to deliver in the past. So let's see the very good side of this age that we are right now, and embrace this creativity with these LLMs.
Yeah. In addition, I'd like to add, like, learn new tools to add to your toolbox. That's always important. But always start with the problem, right? Try to think, and that's something I learned at CI&T. CI&T is very focused on mapping the user journey, right? And back when I worked there with Lucas Persona and other great people there, I learned that it's important to understand from the user journey what are the key source of the users, what are the questions they might have, and how we can use technology to help to tackle those questions or those decision points, right? And I think that's the place where adding AI technology is the mostly pays off, rather than, okay, I have this technology, where should I include it? You might be ending up creating features that are not really useful or not really helping the user. So I'd encourage you to always start with the problem.
Pretty cool. And I can add to that, since I have the heart of the engineer, not the scientist, but I think you both cover very well. As an engineer, just start playing around with the technology. I think Gabriel said, like, look at it as another tool to add to your tool belt. There's a lot of content out there, but start by playing with it. Like, do some prompts, understand how the technology works a little bit, and then go creative and start solving real problems. That way you learn very quick. It's not very complicated to master, because there's a lot of knowledge out there that you can tap on. Wow, this was very cool conversation. I really enjoyed. An hour went by so fast. And as a fun side experiment, while we were talking, I was feeding some information to an LLM here, and I asked it to generate a closing remarks for our little conversation. Since we're talking so much about AI, I said, insert yourself in our conversation and gives a close remark from your point of view using your own words. And it was quite good. So I'll read from ChatGPT right now. So it said, as we journey through this era of technology advances, it's essential to remember we are a reflection of the vast knowledge and diverse perspectives of humanity, encapsulating both potential and limitation. As you integrate AI into your business or personal life, approach it as a collaborative partner, one that can amplify creativity, enhance efficiency, and after insights, yet always under the guidance and thoughtful and ethical human judgment, which I found was pretty cool, right? It's actually very close. It's very good to close with these words. Thanks, ChatGPT. With that, I'd like to thank you, Gabriel, for joining us in this amazing conversation. I'd like to thank you so much, Mika, for joining here too. And we had this great talk. Thank you, guys.
Thank you for having me.
That was unexpected, Rodrigo. Thank you.